Section 2, Video 6. When you have a square that you can isolate in a quadratic equation, we can root, and that will undo a square. When we have a square root, we can undo the root by squaring. So here are some examples of solving for x, or the variable, with a root in the problem. Rules are similar to when there's a square in the problem. We want to isolate the radical, and then we will undo it by raising both sides of the equation to that power. So a square root you would square, a cube root you would cube, and so on. But there's one caveat, and that you have to look out for extraneous solutions. And an extraneous solution is like an excluded value. You get the solution, but if you were to plug it back in, it wouldn't work. That's an extraneous solution, so we must check our work when we are solving radical equations, or equations with radicals. So the same scenario is at play here as with squares. We want to isolate the root, so we would subtract 1, which would give us root x equals 3. We would square to undo the root, and we get x equals 9. We want to check that to make sure it works. If we check that, we get root 9 plus 1 equals 4. Root 9 is 3, plus 1 equals 4. 4 equals 4, and it works. So again, just checking to make sure our solution works. If it doesn't work, it's called extraneous. Next one, we have to isolate first before we can undo the root. So we divide by -6, and we get root 12r equals positive 6. We square both sides, and we get 12r equals 36. Divide both sides by 12, and we get r equals 3. We check that to make sure it works, and we have -6, 12 times 3 equals -36. 12 times 3 is 36. Root 36 is 6. And this checks out. Next one, we have roots on both sides. Well, again, everything is underneath the roots, so this is okay to undo the root at the very first stage, because they're both in roots, and that gives us the equation without the roots. So now we can just solve. So we take a look at this, and we would bring usually the variables to the left side. It's up to you though, which would give us -3 minus 4v equals 9. We would add 3, and we would get -4v equals 12. Divide both sides by -4, and we get v equals -3. We check that into our equation, we would have it work. I will let you do that work to double check that, but I'll just let you know that it does check. Next one, we have a binomial in the root, but again, it's isolated. That whole root is by itself, so we can go ahead and square it. And we get n minus 10 equals 16. So n, that's a 10 there. So n equals 26. If you plug that in, that also checks. And our last one, again here we have a fraction in the root, but again we want to isolate it, so we would add 6, and we would get 1 equals the root of a over 2, which is not a big deal. We just square it. And we get 1 equals a over 2. Multiply both sides by 2. And we have a equal to 2. We plug that in, and that also checks. So this ends section 2, video 6.